Greetings and welcome to eCraft. In this video, I will demonstrate how to implement color detection using an affordable RGB sensor, TCS34725 from the website shown here. The breakout board can operate with both 5V and 3.3V power inputs. The digital interface uses I2C, which can function at a speed of up to 400 kHz. Additionally, there are two optional signals available on the interface connector for controlling the LED and receiving an interrupt input. I came across this website that provides a comprehensive technical summary, specifications, and circuit diagrams of the breakout board. Please feel free to browse through at your convenience. Let me introduce you to some important specifications of TCS34725. This device is capable of sensing the red, green, and blue color components in the light and then converting them into corresponding digital values. You can read the RGB values along with the clear light value through the I2C interface. The sensor chip comes with an IR filter built-in, which enables it to see the colors that are very similar to what the human eye can see. Please have a look at some of the key features that are highlighted here. The breakout board consists of 6 pins, of which 3 are power pins. Additionally, there are 2 I2C interface pins. The optional LED and INT pins can be utilized for specific applications. I'll demonstrate how to connect this to an Arduino shortly. The block diagram illustrates the fundamental components that enable the color sensor chip to perform its functionalities. There are 4 sensor diodes, each dedicated to one of the 3 primary colors, along with clear light. Additionally, there are 4 AD converters that sense these colors and convert them into 4 sets of 16-bit data, which are then stored in 4 registers. Let's examine the circuit diagram of the sensor breakout board. The board has a converter circuit that allows for powering it from either the V-in pin by connecting it to a 5V supply, or from the 3.3V pin using a 3.3V supply. The LED enable signal is connected to the voltage rail using a pull-up resistor, which means that the LED turns on immediately after the board is powered on. You can turn off the LED by lowering the LED enable pin to 0 using an Arduino I/O pin. Please take note of the table located at the end, which provides an example connection between the sensor board and the Arduino board. However, in the setup here, I have connected the V-in of the sensor board to the 5V pin of the Arduino board. Please check out the connections shown next. Let's now check out the sketch. To keep it simple, I have used an example sketch as shown and used the DFrobots library for the TCS34725 sensor. There are 2 important parameters to consider: the integration time and the gain setting. Selecting different values for these parameters will result in different counts. For this demonstration, the integration time is set to 50 milliseconds and the gain is set to 16. The LED enable pin for the sensor is pin 7 on Arduino UNO. However, it hasn't been used in the sketch to turn off the LED. The sketch reads the values of the R, G, B and clear light falling on the sensor. and prints them every 100 milliseconds. The sensor has been connected to the Arduino UNO. A makeshift stand was created to hold the sensor securely in place. However, I wish I had a piece of dark glass to cover the sensor. The sketch has already been uploaded onto the Arduino UNO, so we are now fully prepared to start experimenting with the sensor. Please take note of the values being displayed on the serial monitor window. Observe that the sequence of the color values being printed are blue, red, and green, as this corresponds to the color of the graphs shown in the serial plotter. We will learn about this soon. To conduct the experiment, I have used pieces of paper with different shades of color. Kindly take note of how the values change for various colored papers. Now, let us open the serial plotter and check how the graph changes with different color shades. Note that the color of the graphs matches the corresponding colors AD converter value obtained from the sensor. This is a brief introductory video about the RGB sensor. This sensor has a wide range of applications, including automating the sorting process, analyzing liquids or gases, industrial process automation, measuring light color temperature, or even fun projects and games. Please share your thoughts in the comments about how you would like to use this sensor. Thank you for watching.